The first thing we're going to do is have a look at the information that is given before we even attempt the questions and before we look at the questions. And I find that to be a very helpful technique. Our first bit of information is that AOB is a diameter. So I'm going to go over that as a way of me acknowledging that that is a diameter. And then I'm asking myself, what else does that give me? And what it gives me, of course, is this 90-degree angle. So that's the next thing I'm going to go and mark out, is the fact that I have an angle in a semicircle. So I'm going to go back to the question, and I'm going to tick off the information that I have just added. Does the diameter give me anything else? Well, it gives me one more question for myself, which is there a center? And it looks like there is. I should be told, mostly if you get an O, it is the center, but here it actually tells us that as well. O is the center. When I get given the center, I'm going to go over it to make me very aware of what's going on. What else does the center give me? Center gives me radii. There. Is there another one? Yes, OD. OD is also a radius. The next thing is that OD is parallel to BC. So again, I'm going over my parallel lines, and then the next question I'm asking is, what does that give me? All right, so parallel lines should give me the fun angles, so it should be my corresponding, my co-interior, my alternate. Let's have a look and see what's available. Well, they're parallel. I've got C is 90. E1 must be 90 as well. Okay, then that means I've got a line from the center down to this chord and it's perpendicular. That's interesting. That means that these guys are going to be equal. Okay. Are there alternate angles here? Well, it doesn't seem like anything's going to be useful, so I'm going to stop at that point. I've dealt with the parallel lines. The next thing I'm told is that OA equals 10. Is that special, OA? It's a radius, which means OB is also 10, and it means that this thing, OD, is also 10. And for the most part, if you handle all of the information that's given in the paragraph beforehand, as well as on the diagram itself, you really have answered most of the questions, or you can get to an answer for most of the questions. The first thing we're looking for is angle C, which we got over there. We got angle C is 90 degrees, and that was because of angles in a semicircle. The next thing we want is angle E1. And angle E1 we got to as well. Just remind yourself how we got there. It had to do with DO being parallel to CB. It was to do with those corresponding angles from the parallel lines. So we've got that as 90. And the reason was corresponding angles. The next thing we needed was EC. Okay, so I've put here EC equals AE. And why did I do that? I marked them out as equal. I did it because I saw that O went down to E, and that was a 90-degree angle. And if you have a line from the center that is perpendicular to the chord, well, then that chord is bisected by that line, remember? Okay, so EC equals AE. And our reason for that, we have a line from the center that's perpendicular to the chord. We need to be careful of this one. A lot of people will say line from center bisects chord, but that's the thing I concluded, not the thing I was given. And the rule about reasons is you always have to write down the thing that you were given, not the thing that you got from what you were given. And then we have to calculate ED. That's this bit here. Okay. It's part of the radius OD. OD was equal to 10. We got that from the radii. Okay, so how do I get ED? Well, can I get OE? Can I get O to E? Can I get that amount? Let's have a look at that triangle. So the triangle AOE is a right angle triangle. We know that because we got E1 as a right angle. And now we've got to figure out, can we get OE in the right angle? Well, that's fine and all, but how much is AE? Well, we're given extra information just for this question. We can't use it earlier. We're told that AC equals 16 units. So if AC equals 16, then AE will equal 8. And what we've got is a lovely triangle that's going to work perfectly with Pythagoras. We are working out OE, so it's one of the smaller sides. So I'm going to write my Pythagoras as a minus sum. So I'm going to say OE squared equals OA squared, which is 10 squared, minus AE squared, which is 8 squared. And my reason for that will be Pythagoras. When I work that out then, my answer for OE is 6. So now I've got OE over there as 6, and I need to get ED. Well, clearly, if you take OD and you minus OE, you're going to get ED. So OD is 10, OE we've just worked out is 6, so ED equals 4. For the next one, I'm given the fact that RDS is a tangent. So I'm going to go over that again. I'm going to highlight it. I've got a tangent. Okay, when I've got one tangent, I'm looking for two possibilities. I'm looking for whether I've got tan chord. I'm also looking for tan radius. Okay, so let's double check. Do we have tan chord? We have a tangent making an angle of 40 degrees with a chord. Yeah. Does that chord go anywhere? Does the chord make an angle? If I go to the one side of the chord and the other side of the chord and I take those together, do they make an angle at the circumference? And they do. So that means my B1 is 40 as well. And then what's interesting is that I'm given BC. While I'm there, I'm looking at this and I'm seeing BC and DC are equal. Okay, so that makes D2 also 40 angles opposite equal sides. And I was on the tangent, so is there a tan rad going on here? Let me do that in a different color. I do have a radius because I'm also looking ahead and seeing there I've got O as the center. Okay, so I've dealt with the tangent. I'm also now going to deal with the fact that I've got a center. So because that's the center, I've got this coming out there as 90, and then this one's also 90. I'm just going to make it really big so I can cover all those little angles inside. Do I have anything more because of the center? Well, this one, O1, is going to be double A. I'm just wondering if I'm going to need to use that. All right, let me do it. Let me say that is a 2x, and let's have that as an x. Because these are numerical riders, I expect that my 2x and my x will get numbers at some point, and then I will just make a big mess of my diagram and rub stuff out and add more numbers in, and that's okay. I really do think that geometry, if it is messy in a way that you can see what's going on, is really helpful. Right, so B1 is the first thing I need to get. B1. Okay, did I have it already? I did. There's B1. It was the 40. Right, so B1 equals 40 degrees, but how did I get there? It was tan chord. The next thing I need to work out is D2. D2 I've also already worked out as that 40 over there. And what was that about? That was about angles opposite equal sides. The next thing to get was C. Let's see what C got to do with the previous two. Most geometry questions scaffold really beautifully like this, and the one will lead to the next. Okay, C, I've got 40 in the same triangle. This one must be 100, sum of angles in a triangle. And then we need to get O2. O2 is over there. How can I get O2 from what I've already got? Well, I'm going to bring out a highlighter for this. This is quite hard to see sometimes, but O2 is coming from B and D. It's the reflex angle made by B to D, and then its little one that goes with it, the angle at the circumference is 100. So that makes O2 double C because the angle at the center is twice the angle at the circumference. And now I can get O1 because these guys are all around the same point. Okay, so I'm going to be messy and I'm going to be scratching out this 2x because to get O1 it's going to be 360 minus 200. So O1 is obviously going to be 160, which makes my x by a here half of that, which is 80. I'm just adding that on as I go. So O1 is 160, angles around a point. Then I need to get D3. D3 is inside there. And I just like to point out that we have 90 degrees. We got that earlier. I've got the 40, I've got that 40, and now I need to get D3. But they all add up to 90, right? So D3 has to be 10. What's my reason for all of that? It's going to have to do with tan radius and then complementary angles. I only need to write in tan radius because that implies the 90 anyway. I can also put in here complementary angles if I want to, like one would do supplementary angles. I think it's covered by tan radius, but if you're ever unsure, always add extra reasons.